In this lesson, we're going to go over Big Idea 1, Standard 2, drawing Bohr diagrams. So first, when you are drawing the nucleus, I like to use a dotted line. And when I am drawing our energy levels or the electron shells, I use a solid line. And the reason that I like to do that is because it's easier to see where your nucleus is. This way I know that this is the nucleus and it's not the first energy level. So that means that you should not have any electrons on your dotted line because we don't find electrons in the nucleus. Next, you are going to list the number of protons and neutrons in the nucleus. My recommendation is to write protons equal, neutrons equal. If you were to try to draw a bunch of little dots representing protons and neutrons, it's really easy to draw too many, or maybe if I'm grading it, I can't tell the difference between the protons and neutrons. So we could say protons equal 3, neutrons equals 3. I can very clearly read how many of each there are. Let's talk about electrons. So electrons go on those energy levels or on those shells around the nucleus. So again, that was our big discovery from Bohr. That's how he improved upon the Rutherford model. He found that electrons are in energy levels. In this first energy level, we would call this n equals 1, the closest energy level to the nucleus. It can only hold a maximum of 2 electrons. The next energy level, we would call this n equals 2. The second energy level can hold 8 electrons. The third energy level, this would be the third ring away from the nucleus, n equals 3, can hold 18 electrons. We will never draw something this big, but let's say we were to get to n equals 4 or greater. Can hold 32 electrons. So let's look at a few examples. Draw a Bohr model of magnesium 24. So the first thing that we need to do is we need to list the number of protons and neutrons in the nucleus. So we need to figure out the number of protons and neutrons. So I know that this is magnesium. So I can grab my periodic table. Magnesium has an atomic number of 12. So that means that magnesium has 12 protons, and protons are in the nucleus. Since it's magnesium 24 minus 12 protons, that means there must be 12 neutrons. So again, we can add those neutrons to the nucleus. Next, whenever we have this notation system, it's always going to be for an atom. If it was an ion, we would use our A to Z notation. Always assume that this notation system is going to be neutral. So if there are 12 protons, there must also be 12 electrons. We can't just put them wherever we want. The first energy level can hold 2. The second energy level can hold 8. So I have 2 in the first energy level, 8 in the second energy level. That gives me 10, 11, 12. You might also be asked to label a few things on your Bohr diagram. So you could be asked to label the nucleus and label each energy level. The energy level closest to the nucleus would be n equals 1, and then we just number out. All right, try one on your own. Draw a Bohr model for a nitrogen ion with a mass number of 15 and a charge of -3. So pause the video, take a minute, try to draw this one on your own. Once you have your model drawn, unpause the video, come back, check and see how you did. So before I even start drawing this one, I want to figure out the number of subatomic particles that I have. So I know that this is nitrogen. So if I head to the periodic table and I find nitrogen, nitrogen has an atomic number of 7. That means that there has to be 7 protons. Remember that the mass number is protons plus neutrons. So if I take my mass of 15 and subtract out my 7 protons, I have 8 neutrons. Electrons. The charge is -3. Since it's negative, there's more negative charges than positive, so I know there has to be more than 7 electrons. And since it's -3, there's going to be 3 more. So I would have 10 electrons. Protons go in the nucleus. Neutrons go in the nucleus. electrons go on the shell? 2 in the first, up to 8 in the second. So I already have 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, if you were asked to label, you should be able to label the nucleus and each energy level. Last problem. So if I give you a Bohr model, you should be able to analyze it. Alright, so protons in the nucleus, neutrons in the nucleus, 11 protons, 12 neutrons. Electrons are in energy levels. So, given this model, A, determine the mass number. B, determine the charge. C, we are going to write our symbol. Using this notation system. So first, mass number. The mass number, again, is equal to protons plus neutrons. I have 11 protons and 12 neutrons, right there in my nucleus. So my mass number is 23. When we are looking at the charge we are going to look at protons and electrons. Protons are positive, and I have 11 of them. Electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Electrons are negative. If I have 11 positives and only 10 negatives, my charge is going to be +1. When we're writing the symbol, X is the element symbol. The identity is determined by the number of protons. This ion has 11 protons. Atomic number 11 is sodium. The top number, A, represents the mass number, which is 23. The bottom number is the atomic number, which is equal to the number of protons, which is 11. B is the charge. The charge is +1. You could also leave the 1 out. So you can do 2311 sodium plus. Either way would be correct.